So for number 2, 3.6 part 3, this is another complete graph analysis problem. So we have a lot of parts to do. Before I do anything, I want to factor. So this will be 3x, and the denominator is a difference in perfect squares. So this will be x plus 1 and x minus 1. And nothing really cancels out here. So when this happens, you can really refer to either the original or you can refer to this factored form. Both of them are perfectly okay. But also because nothing cancels, that means that there is no holes in this graph. For the part B, we want to set the numerator equal to 0. So I'm going to refer back to the original version of the function. So 3x is equal to 0, and x is going to be equal to 0 then. So as a point, that'll be the point 0, 0. For part C, we need to set x equal to 0. Again, you can plug it into either one of these. So I'll plug it back into the original. So this will be 3 times 0 over 0 squared minus 1. And this is equal to 0 over negative 1, which is equal to 0. So this is also the point 0, 0. My zeros look like U's. There we go. So we actually kind of knew that this was going to be our answer because as an x-intercept we got 0, 0, and 0, 0 is the origin, and that counts as both an x-intercept and a y-intercept. So it is good that it is consistent here. Looking at part D, I want to set the denominator equal to 0. For this one I'm going to use the factored version because I'm going to have to factor anyway, so I've already done that. So x plus 1 and x minus 1 is equal to 0. So we're going to get x is equal to negative 1, x is equal to positive 1. And those are two vertical asymptotes. For part E, there we go. For part E, I want to compare the degree. So I'm looking at the original version of the function, and I have a x, so a degree 1, and an x squared on the bottom, so a degree 2. So the denominator is higher. So in that case, it's going to be y is equal to 0. So this is the horizontal line, y is equal to 0. Is going to be your asymptote. For part F, this is the domain, and again, it can't be any holes or vertical asymptotes. Now, I don't have any holes on this one, but I do have vertical asymptotes. So I'm going to start at negative infinity and work my way up to negative 1, and then negative 1 to 1, and then 1 to infinity. So then for part G, this is does it cross the horizontal asymptote. So we want to set the function equal to the horizontal asymptote. So this will be 3x and x squared minus 1 is equal to 0. I'm going to call this 0 over 1 because I do want to do the solve like a proportion. So I do want to do the cross products here. So for this, if you cross multiply, we get 3x is equal to 0. So x is equal to 0. So what this means is that it's actually going to cross at 0. So it crosses at x is equal to 0. Again, you can cross horizontal asymptotes in the short term. The end behavior, it's still going to approach it and not cross it, but locally it could cross it. So I want to graph this. And I know that I'm going to have asymptotes at 1 and -1. I also know that I'm going to have a horizontal asymptote at y is equal to 0. Now this is actually the axis here. So a lot of times people like to draw it a little bit above the axis so that you can see it, but it's technically right on the axis. Okay, so then I want to graph the function, and you can always graph it on the calculator to get a better idea about the picture, but it's going to look like this, and we always draw arrows when it approaches the asymptotes, and then the inside part is going to look like this. So you will notice that that point right there in the origin, not only is that an x-intercept, but it's also a y-intercept, and it's where it crosses the asymptote. So there's definitely a lot going on at the origin.